Welcome to EDU World Space.
So in this question, what we have over here is that the material given to us is a steel boiler, right? And this material, it is zero point 0.5 inch long, right? And we need to determine the pressure in the boiler when the gauge elongates, right? It elongates zero point 0.2 into 10 raised to power negative 3 inch, right? And the boiler has a thickness of zero point 0.5 inches, right? Now its inner diameter is equal to 60 inch. Now we need to determine the maximum x y in plane shear strain in the material, right? And the elasticity is equal to 29 into 10 raised to power 3 ksi, and the epsilon is equal to zero point 0.3, right? So let's start with the solution. Now what we're going to do is that we are going to recall our previous knowledge of chapter number 8, right? Now in order to use equations from chapter number 8, the ratio of the radius to the thickness, it must be greater than equal to 10. So let's check that first. So in our case, the ratio is equal to 30 divided by zero point 0.5, and that is equal to 60, and that is clearly greater than 10, right? So it means that we can invoke the equations included in chapter number 8. Now, the part of the chapter number 8 that describes the given object is that cylindrical vessels. Therefore, equation 8.1 and equation 8.2 will come in handy for finding the pressure, right? So let's start with first of all finding out the principal stresses. So sigma sub 1 is equal to P times R divided by T, and sigma sub 2 is equal to P times R divided by 2T, right? Now what we are going to do is that we are going to divide sigma sub 1 by sigma sub 2. So we have 2, right? And this relationship, we can form a relationship from here, right? So that would be sigma sub 1 is equal to 2 times sigma sub 2, right? Now as you can see over here that this P is not a parameter, it is a pressure, right? Gauge pressure, meaning it is what we want to find. So solving one equation for P will give us um, the value of P, right? So P is equal to, it is very similar to the question number 36, right, that we just did. So 2 times T times del 2 divided by R. Now this above equation has two unknowns. The first is the pressure, right, the one we are seeking, and the other is the plane stress, right, this one. Notice that theory states that the sigma sub 2 is perpendicular, right? There is sigma sub 2, it's perpendicular to the cylindrical cross section area, right? So, and sigma sub 1, it is parallel to the cross sectional area, right? Um, this is in like x direction, right? If I want to like figure out the direction, this is the x direction and this is the in the y direction, right? So it means that we can write that sigma sub x is equal to sigma sub 2 times sigma sub y, and that is basically equal to sigma sub 1. Now what we are going to do is that we are going to use the Hooke's law for two dimension, right? Hooke's law for two dimensions, and we can find a relationship between the stress and the strain, right? So the equation for the strain is 1 divided by E, right? Oh, we know this equation. Um, it's very simple and we have used it a million times, right? So the stress for y, and there is no z component, so it is equal to 0, right? Now I want to simplify this equation, so I have 1 divided by e sigma sub 2 negative epsilon sigma sub 1, right? Now, as you can see, is that we can simplify a little bit more, right? So let's do that. So I have 1 negative 2 epsilon divided by e. Now what we're going to do is that we have epsilon sub x over here, right? So we can solve it for stress. We can rearrange it for stress. So we'll have sigma sub 2 is equal to e times epsilon sub x divided by 1 negative 2 epsilon, right? So after doing this, we need to recall the elongation equation, right? So after recalling elongation formula, so that is simply the strain is equal to the change in length divided by L, right? And in our case, this is del L, right? Divided by the strain gauge length, right? Strain gauge length. Now we have all of these values, so just plug them in over here, and we'll get that it is equal to zero point 0.2 into 10 raised to power 3 divided by zero point 0.5, and that is equal to 4 into 10 raised to power negative 4, right? And now we can find the stress, right? So for stress, just plug in the values. So we have 29 into 10 raised to power 3 into 10 raised into zero point 0.4 into 10 raised to power negative 4 divided by 1 negative 2.3, right? 1 negative 2 into 3, right? So when you calculate it, you get that is equal to 29 ksi, and from this we can find out the value of sigma sub 1, right? So that is 2 times sigma sub 2. So 2 into 29 is equal to 58 ksi, right? Now what we're going to do is that we need to substitute it in the pressure equation, and we can find out the pressure that is what we are seeking from the beginning. So P is equal to 2 times T sigma sub 2 divided by R, right? And that is equal to 2 into zero point 0.5 into 29 divided by 30, right? And that is equal to 0.9666, right? And since these two principal stresses have the same sign, it means that we need to use equation number 9.13, and it gives us the absolute maximum shear stress. So the absolute maximum shear stress is equal to sigma sub 1 divided by 2, and plug in the value of sigma sub 1. So we have 58 divided by 2, and that is equal to 29 ksi, right? So this concludes